All right, so let's look at number 3. Let's notice if we look at our null and our alternate hypothesis that we have P, we have a proportion. So we want to do a proportion hypothesis test. And our test statistic for a proportion is this thing right here. All right, so first though, we need to figure out what P hat is. And let's recall that for p hat, we need the number of successful observations over the total number in our sample space. So let's go back here for a second. Nope, wrong one. 451. And I'll go ahead and put that into my calculator and get a decimal. And I'm going to take that about 4 decimal places, so 0.4723. And let me make my 7 look more like a 7. There we go. Okay, now let's plug it into here. We're going to have 0.4723 minus our proportion from the null hypothesis. Let's go back and see what that was. It was 0.41. Okay. Oops, I don't know why it went to Excel. Okay, so 0.41 over the square root of 0.41, 1 minus 0.4 minus 0.41. That's going to be 0.0623. And then I'll put all of the bottom into my. That ends up giving me 2.69. The next 2 digits are 0, 0, so I can probably leave that test statistic at 2.69. I don't know what it told us to round to. 3 decimal places, so 2.690 is what we'll put there. And now, all right, so let's go back to our page for a minute. Let's remember alpha is 0.10. It's a right-tailed test. So I'll go back to my page here for a second. And if we think about a right-tailed test, we're looking at the normal curve, and the right-tailed test is going to end up with alpha over here on the right. And I did not put that 0.10 in very well, but there's going to be 0.10 over there on the right-hand side. But let's remember when we look things up in Excel or on our table, we always get this area over here to the left when we look things up. Well, if the right side is 0.10 and this is 0.9, because it always adds up to 1. So let's look up 0.9 in Excel, and we're going to get this value that is right here, and this will be our critical value, this value right here. All right, so I will look that up in Excel. Let me pull up Excel now. I got all kinds of stuff in here, but we'll just go into one of the blocks. Equal norm.s.inv, and I want to put in 0.9, And it tells me that that z-value is 1.28, we'll round to 3 decimal places, like it said, 1.282. All right, so 1.282. Let me go back here. Um, so on my picture, this is 1.282. Now, since this is a two-tailed test, I'm going to erase this because it's deceptive. Our rejection region, we will reject the null for any z-value that falls on this side to the right, because our alternate is a right-tailed test. So anything that falls to the right of 1.282, which our test statistic does, 2.690, is greater than the critical value of 1.282. So we will reject the null. All right, so let's make sure we're putting these in the right place. This is our critical value. This is our test statistic. So 1.282, I believe, goes in the first blank. Let me go back. So let's notice this one says test the claim that the proportion is our P, of people who own cats is significantly different than 20%. Now, when we see different than, that's always a two-tailed test, or not equal to for our alternate. So we're looking for P, since we have a proportion, and we're looking for not equal to for our alternate. And let's notice that looks like this last choice right here. All right, then that makes this a two-tailed test. And then notice the next one. They give us the sample proportion instead of us having to figure it out. They give us that the sample has 200 people in it, so that's our N, and 15% own cats. So our 15% is our P hat. All right, so now this one we're using the p-value. So we first find our test statistic. We'll look up our test statistic. But recall that for a two-tailed test, our test statistic, in this case, 0.15 minus 0.2, is going to end up being a negative test statistic when we get done. On top of the test statistic will be negative. When we get that negative test statistic, we'll look it up in Excel, and because it's a two-tailed test, whatever we get in Excel will double for our p-value. And then, of course, we'll have to make our decision whether to reject the null hypothesis or not. Okay, now let's go to 7. I think 7 was a different type of test. It is, okay. So 7, let's notice we have our mean symbol in our null and our alternate. So we're going to do a test for the mean. Now, on the other hand, what's important to realize here is so here's our test statistic for a t statistic. It's pretty much the same as the z, except we're going to use the sample standard deviation. All right, so let's figure out what to plug in here. We have our sample mean minus our population mean. I'll go back here for a minute. Our sample mean is 60.2. Our population mean we get from our null hypothesis is 50.1. So 60.2 minus 50.1. All right, so let me go back and write that. All right, so I wrote out the intermediate steps just in case you needed them while you're putting things in your calculator, but here is our test statistic. We want to find the p-value, but let me, well, we'll go ahead and put this in as is into Excel. Let's remember, though, this is a t-distribution, small sample size, and we don't know the population standard deviation. So we're going to put this in to a t-distribution with a degrees of freedom of 7 minus 1, or 6. So we will have equal t dot dist. Our x value, go back here, was 3.29902. 3.29902. Degrees of freedom are 6, and we want to put true. And that is 0.991786. All right, now let's go back for a minute, because if we look at our alternate hypothesis, its mu is greater than 50.1, and remember 0.996 is to the left of is the left side, and we want the right side since we have a right-tailed test here. So we need to subtract this value in Excel from 1. So I'm just going to do equal 1 minus 0.99178.6.